see what we do. Okay, let's do crystal, which is where I was earlier, right? Crystal, crystal, crystal. Let's check it out. Oh, I should check my sound. Yeah, can I hear it? Hold on. Yeah, I think I can hear it. Hold on. The music seems too loud. Let me adjust it down a bit. Okay, I'm gonna leave it down. Okay, let's go to crystal. So we were, yeah, crystal. So I didn't know if it was installing right. So I'm gonna say practice mode local, and we're gonna go install. I think whatever I tried to do before, I don't know if it worked actually, so I'm gonna see if we can get it off of brew. Let's do that. That's usually what I like to do first, because if that works, then it's usually just quick. And I just want to get up and running pretty quickly. So let's see what it does when I try this. Oh, that didn't take too long. Not too shabby, not too shabby. All right, so let's go find my file. Crystal. Crystal. Hello world. Okay. So what's it do now? Crystal spec. It says cannot find LPCRE. I feel like I should know what that one is. Like something POSIX compliant regex or something? Is that what it is? I don't know, it might be. Okay, so it didn't work. No dice. So we probably want to install this, I would assume. Okay, so it's snap, cache, crystal run spec. Interesting, interesting. LPCRE. Okay, so let's look for this. Crystal. We got this message. All right, cannot find. So we're going to install whatever this libpcre is. Perl compatible regular expression. Never mind. I should have said that in the first place. I second guessed myself too much. Okay, but that's not the point. At least, well. Maybe it is. Okay, so it says development package for libpcre. Let's try doing what this person says. Okay, yeah, it's a lot just like they said, and then they said they maybe grep dev. Okay, sure. And then which one, if any, do we think? Camel, Rust, Lua, GHC. Interesting. Okay. what is APK? Okay, I don't think that's it. Okay, let me test again. Running tests via crystal spec. Let's see, I don't suppose any of these was mentioning crystal. A lot of them did mention specific programming languages. Let's see. C bindings. Okay, cool, cool. Ruby. Crystal. Lib. PCRE. Okay. I think this first one looks like it's probably it. Okay, so let's go sudo apt get install lib pcre2. I'll feel dumb if I do feel dumb already, regardless of how this goes. Alright, sure, I'll install it. Okay, what does exorcism say now? Same thing? I'm guessing probably same thing. Nope, nope, that was it. Hey, that was it. I actually feel a little bit less dumb. Okay. Got goodbye Mars. Okay, cool. So, what's in source? Just hello world. Okay, so we're gonna go vim source slash hello. Okay. Hello world. Okay. Test. All right, that seems neat to me. Let's submit. Okay, let's take a look. All right, so we did the hello world, but of course that's the easy one. Now we've got to do the protein translation, which is probably pretty easy too, honestly. Okay, so let's mark as complete. Okay, so here's Crystal, so let's go into docs. And we're gonna find protein translation. What is it? Protein translation, Crystal. Okay, so we're gonna hop on over to this. Okay, let's look at the README. Okay, so this is what we'd seen before. We have this table. Okay, so for creating our table, let's go into docs and search. Do we have a dictionary? Let's take a look. No matching documents. Okay, do we have a map? We have a hash. Oh, okay, a hash. Fair enough, baby. So this is how I guess we're gonna do it. We're gonna use a fat arrow pointing from a key to a value. All right, let's do it. So we're gonna use these keys and values. Let's find our source file. Okay, so I'm gonna paste that. Whoops. And we're gonna say, let's see. So when we declare or assign, let's take a look. Assignment. We can assign to local, instance, or class. Okay, fun. The constant just has big letters. Love it. Okay, that's cool. So here I'm in a module. Oh, I'm in a module, so what do I want? A local, an instance, or a class? Self.proteins. What? Oh, is my keyboard going crazy? Maybe it's... I hope it's okay. All right, so a class variable, can I just put that in here in module protein translation? Self.proteins. Okay, I am going to call it maybe a class variable. Let's see what happens. So I'm going to say 2@, and I'm going to put a table equals, and then I'm going to put curly bracket, and then again, okay, so now we're going to make this into a hash, right? So let's see, so this will be our key. We'll put fat arrow to our value. Okay, and then a comma, and that's how they're all going to be. Okay, so let's come in here. So that will be like this. Yes. Okay, so we've got these. All right. Whoops. Okay, like that, basically. All right. Making our table. So AUG, yep. So far, so good, I guess. And down here, we do the end. Okay. So I think that's basically it. Let me just finish up. Okay, methionine. Okay. Okay, so that is our hash. Okay. So then when we talk about assignment, if we have it as a class variable, do we use the double at again when we refer to it? I'm guessing maybe yes. Let's see what it says. Yeah, we use the double at either way, I guess, so it's probably fine. Okay, so do we want to use, like, recursion again? It probably doesn't matter. In fact, I'm almost tempted to flip a coin for it. Let me see. Where's my coin? I'm gonna flip a coin for it. Ah! I probably should do better posture. Oh. Alright, I've got various coins here. It doesn't matter which one. Alright, so here's a penny. Heads, I'll use a loop. Tails, I'll use a recursion. It looks... I can't see where it landed. Over there somewhere. Here, how about this one? That is tails. I'll use a recursion. How about that? Tails, recursion. Okay, that works for me, baby. So, we'll start by saying if strand, and then let's look. Crystal string length. Interesting. So we're talking about strings. If we want to get the length of it, this puts, that's Ruby-like, right? That's what you put in Ruby, is you do puts. Anyway, so size. Okay. So if strand size is less than 3, and then okay, let's look at control flow as well. Okay, so we put this question mark for something, but I don't think we need it here. Okay. So if strand size less than 3, return empty array, I guess. So that's cool. Crystal array. Okay, that looks good. Okay, so if it's less than 3, so that's our base case. So then otherwise we need to say if, well, actually, let's just put this as an or. And then we were just looking at, like, Yeah, so we'll use double pipe or. Okay, so if strand size is less than 3, or, well, actually, no. We want to check that first. And then, yeah, we can say, or, and then what about a substring? Indexing substrings. Okay. Convenient. Extracting substrings. Okay, so we'll do it with a comma. Okay, so this time, oh man, interesting. Okay, so this time we specify the start index and the length, which I'm probably less likely to screw up than the way I screwed up the F# thing. So, it'll be at table sub strand sub 0 length 3, right? And then we'll say equals stop. Okay, so in either of those cases, that's what we'll do. Okay, so then otherwise, we will return table substrand 0, 3, and then plus, let's see, crystal, actually here, we're in array. Can we concat? So we can concat like this. Splat expansion. Okay, yeah, let's just do that. Let's just use that star. So I'll put comma star self.proteins strand sub. Okay, but then for the other thing with substrings, we can do it like this, but what if we just want from a certain place to the end? So here, message size -6 -1. Okay, so they subtracted 1 because they were wanting to get rid of that. Okay, so range with 2 dots. And then, okay. Can I put -0? Maybe. Let's take a look at this. Range. Okay, let's do this. Endless range. That sounds good to me. Okay. So it'll be 3 ... Okay, but again, am I starting at the wrong place if I do that? I think maybe? No, I don't think so. Okay. Okay, let's not download again. Let's just test. And it says, for empty arrays, use of element type. Okay, cool. Sounds good to me, baby. Of string. Okay, let's hit it again. Okay, cool. So 30 examples, 0 failures, 29 pending. All right, so we'll go into the test, or the spec, I guess. Spec slash Okay, so in the spec, I have pending, and do I just want to change pending to it? It looks like probably. So let's go wherever we have pending, I'll make that say it instead. Global. Okay. Oh man. Okay, so actually just 2 failures. Okay, that's not too bad. So this one, okay, hold on. So it says unknown amino acids not part of a codon can't translate. Expects raise argument error. Okay, so got key error missing hash key XYZ. Okay, fair enough. And the expected was raises argument error. Okay, so let's look at that in the spec. Expect raises argument error. They put in AUGU. Okay. Interesting, interesting. Okay. So this should be equals 0 probably. And then here it should be if strand size greater than 0 and strand size less than 3. Raise, let's see, what's crystal raise exception handling? Okay, so we will raise exception dot. Okay, so we do raise, right? Raise, okay. And it's argument error. Let's see what that does. Oh, right, okay. Raise argument error. Expect exception or, okay. Expected argument error, but nothing was raised. Okay, so let's look. Argument error. Let's search for it. Argument error. Okay, argument error dot new. Okay, let's try that. Dot new. That's what they did here. And then say incomplete codon string. Okay. All right, so now we just have the one failure, which is that they're not part of a codon. All right, so that's where we need to say, let's see. So we're using a hash, and we want to check if something is in the hash, right? Whoops. Oh, this is probably where I want to be. My posture's pretty bad. Okay, so we created it using a hash literal. That's very fun. So we want to check whether some key is in the hash. Something like has probably. Has would be a good one. Has key. Okay, yeah, let's do that. So if table has key, right? Strand 0, 3. Then we do this return. And so then if it didn't have it, then we raise argument error.new invalid codon string. That's not too bad, but it didn't do it. Okay, so missing hash key. Oh, so did get missing hash key. Okay. Didn't do it right. So it was supposed to be, so if table has key, then we would return this. Okay. Returns true when key given by key exists, otherwise false. Oh. I thought that had been right. Strand 0, 3, which is what we use here. Oh. Okay, I don't quite see what I did wrong there, but let's see. So test. Okay, so we got a missing hash key error. So that's not what we wanted, but it does give us stack trace that could be helpful. So we do see that it was at 25, 28. I mean, there's only one place it could be, right? I think. 25, 28. Oh, no, it's right here. Okay, never mind. So we can't do that. So we have to set, yeah, it's a pretty obvious mistake now that I see it. Good to look at the stack trace now and then. So if table strand 0, 3 equals stop, then return of string, and here we get rid of that. Yeah? Okay, let's submit. See, that wasn't so bad. Yeah, let's submit. Okay, cool. So, yep, that's an easy one. And it says solved. Okay. Okay, let's close these down and we'll go to the next. Yeah, that wasn't so bad. That took a time, the amount of time that I spent on that seemed pretty reasonable to me. And so I'm much happier than I was earlier. So now let's do C sharp. Yeah, baby. Yeah. Let's join the C sharp track. Practice mode on my local machine. Okay. So I think, yeah, we just need to do .NET. The funny thing is, I don't think .NET version actually works. Oh, no, yes, it does. Okay, wonderful. It wasn't before, but I messed around until apparently it does work now. Okay, so let's do the hello world for C sharp. Very fun. C sharp. Hello world. Let's do it. It says .NET seems a little slow on my machine. I don't know. Okay, cool. So we see the goodbye Mars, so looks like we're ready to go. I think this will be quite a quick one. So we need to go into the hello world CS file and just change this. And test again. So now it should be fine. Submit. Hello world CS. Cool. Okay, so we'll make sure that's good, and then we'll go on and do the protein thing. And this one will likely be pretty quick. So that guy's processing. Exercism is such a great site. Absolutely amazing, in my opinion. All right. Okay, passed. Mark is complete. Okay, so now we're gonna go back and we're going to copy here. Okay, so we're gonna go back to protein translation, and it's gonna be the same thing we just did, but presumably even easier because I have significant experience with C#. Not for a while, though. But regardless, I think this is going to be pretty simple. So let's say public static. In C#, is it called a dict? Like, it has been a while. I think it's called, yeah, it's called a dictionary. These should be small. Go. Table. And then we'll just say equals, and then I think, what's the good way to initialize it? C# initialize dictionary. Okay, they're just equal signs. Right? I think. Okay, so int. No. Oh, is it just a comma? Okay, cool. This language is a little verbose, isn't it? But not in a bad way, I don't think. Okay, so we'll have things like this. Let's get our table again. So we need these codons. Okay. I'm a bit slow at typing these. I probably ought to find a better way. Okay, so it's pretty much just gonna be like that each time. Let's get rid of this one. Uh-oh. They're all trying to nest way deeper than they should. Okay. Okay. Phenylalanine. Okay. So now, yeah, basically. Okay. So, oof, really ugly looking. Okay. Serine here, it looks like. I think so. I think so. All right, that is formatted so nasty. Let's see. C# command line format. Oh no, don't answer me that. Ah, okay, I'm just gonna leave it alone. No. No, I'm trying to get something done here. Okay. Maybe some other time. All right. Okay, so let's try. Okay, well, let's look in here again. Okay, so we don't want to do this. We will just say if no, excuse me. If strand length okay, yeah. If strand length is okay, so in the other one we said we were gonna throw an exception if it was um like less than 3 and greater than 0. So here we will throw And then let's see, C sharp argument exception. Yeah, let's throw argument exception. Let's see how it shows. Throw new argument exception. Okay, yeah, let's do that. We'll just say incomplete code. Okay. Then we will say we need to check the dictionary to see if it has a key. Methods contains key. So then we will say if table contains key, and then let's see, what's C sharp substring? I think it's probably just called substring. Let's see. And it is start index through end index, or is it through length? It's through length, okay. Contains key. I guess it doesn't matter in this case. So strand substring 0, 3. Okay. Then we'll do the rest of the work, right? So we'll say if table strand substring, and for the dictionary, when we get something out of it, can we use that syntax? Or do we have to say get? Yeah, we can use this syntax, right? Okay, cool. Equals stop. Okay. Then we will say return new array list. So don't we have to, like, for an array list or for a dictionary, don't we have to put an include? Don't we have to, like, include system collections generic? I think so. I think we have to say using system collections generic. Probably. Okay, so that's in that case, and so then in this case we return new array list string, and inside of it we put table strand substring 0, 3. Okay. And then for array list, C# array list. So for array list, we can, like, concat or something. Or no, what can we do with it? Interface list. Methods. Add an item to the list. C# list join. No, no, not join. Okay. We have a good answer here. So they did choose concat. Concat. Oh, wait, it doesn't return, it returns a string array. What the heck am I doing? C# array. Maybe I should have done this one in a loop. In fact, I think I am going to at this point. It seems easier to think about if it's like more like a recursion, but it could definitely be a loop. All right. So in that case, we would go for int I equals 0, I is less than strand length. I plus equals 3. Right? And then this stuff, let's see. So certainly this part would go in here, and this would become I. So here we would say list or array list string result equals new array list string. Like that, I think. And then here we would return result dot to array or something. Let's see. Yeah, just to array. To array. Okay, so that part seems fine, I guess. And then but we first have to check this. So this will go here. And let's say if not, so then here we will throw new argument exception. Invalid codon. Okay, sure. And then here, if we get to this point without having returned, or actually no, at this point we just do this same thing. Okay, so then here, let's delete that. So if it's stop, okay, so then at this point it's not stop, and so we're gonna say result add table strand substring I3. Actually, you know what? Yeah, this is simpler than what I was trying to do before, probably. So that seems fine. Let's test. So it says expected semicolon. All right, fair enough. Here probably, right? It said 25. Yeah, I think it was that. Okay, so array list could not be found, missing a using directive. Okay, so let's see the using directive for array list. C# array list. So it's system collections. Okay. Okay, non-generic type array list cannot be used with type arguments. For some reason I thought it was a generic type. Okay, so let's not do it like that. Huh. Is that right? An explicit excuse me, an explicit conversion exists. Okay. Okay. Failed one. All right, so we failed the only one. It says unable to cast type system object to system string. Okay, so what is the deal with array list? Why did I think this was the thing to do? Generic array list? There's got to be something like that. Oh, we just want list. Okay, okay. I think this is what we want. And then let's get rid of this. Now it says past one. Okay, so now let's go into the tests. Okay, so let's get rid of the skips. Okay. Past 27. Bangarang. That's not too shabby, actually. Let's submit. I'm eager to move on. Okay, let's take a look. So that was C sharp. Very nice, very nice. Okay, so passed. I'm gonna say mark is complete, confirm. And there we go. Okay, so let's close all this C sharp stuff. Let's see what the next language is. I haven't really been looking ahead. I know they've got I think they have 61 languages already, and there might be more before the end of the year because they haven't released everything yet. So that's very exciting. Anyway, so there we go. So now we're gold on leap, reverse string, raindrops, Roman numerals, and protein translation. So next is list ops, and our language is Gleam. Okay, so that's cool. So let's join the Gleam track. Practice mode, local. Okay, install Gleam's tooling. Let's take a look. Yeah, let's try this. Okay, cool. So that is good, I guess. Let's try the hello world. I love it. I love it. I love it. I love it. Okay. So it's going to be Gleam test. Let's just try the exercism test, as I usually do. Okay, looks pretty good, I guess. Okay, cool. Awesome. So let's do source/hello world. All right. I always like to see a nice hello world that doesn't look too complicated. And that was definitely one that did not look too complicated. Okay, let's take a look. All right, passed. Awesome. I am loving it. Okay, so now let's go back to list ops. So I don't know what this is, but we're gonna find out. List ops. Okay, let's see what the README says. Okay, list ops. Implement basic list operations. Length map reduce. And so, okay, it looks like it's several of them. Append, wait, length, concatenate, filter, map, fold L, fold R, reverse. Okay, cool. Let's see. Let's take a look. I'm a little nervous because I've never seen Gleam before. But should be cool. Okay, so here we go. So we've got a bunch of stubs. Love to see it. All right, I guess let's do them one by one. So this first one is append, and okay, so we're gonna get a first and a second. Wait a minute, wait a minute. So concat, they're all lists. Okay, okay. All right, so let's find out a little bit about what a list is like in Gleam. hex docs. Okay, so here's Gleam and list. Okay. And the instruction says what? Without using existing functions. Okay. But it looks like this is probably going to be pretty easy even without using existing quote-unquote functions. I mean, I don't know. Let's see. This one at least. I don't know about all of them. Joins one list onto the end of another. Okay, so append is a built-in, and we are going to create our own implementation. In linear time, traverse and copy the first list. Okay. So we're gonna do, I guess, a case where we need to match if the list is empty so that we have a base case, right? Right? So this pattern matches when the list is empty. So in that case, we are going to return, and let me see, so functions. So whatever is, hold on. So if in the case where first is empty, then we just return second, right? Okay, so then the next case, we have first element and rest. Like that, just 2 dots. Fair enough. Okay, so in this case, we're going to go append, and we're going to pass rest. And then here, we are going to pass second with first element at the end of it, right? So let's take another look. So there's a dedicated syntax for prefixing to a list. All right. So that will be... No, this will reverse it if I do it like that. It needs to be second, and then... So this needs to be rest. So this needs to be second first element. I don't know. Like, it seems dumb. Like, in reality, it seems like if I'm gonna just do that, it seems like if I was just gonna do that, then I should just put them all together at once. Okay, so syntax error, I wasn't expecting what? Elements? Oh, okay, okay. So it says reverse it once you're done. Where's reverse? Okay. But here it said what? Without using existing functions. So I think reverse would count as that. And in fact, we're going to be implementing reverse. Oh, well, okay. In that case, maybe we should implement reverse first and then use our reverse. Right? So I'm going to put to do here. And then here I'm going to put, we're going to reverse this. So it's going to be case again. Okay, so we have the empty case in which we just return nothing. And then the other case is we return first element rest, and then we just return reverse, no. Shoot, this is gonna mess me up. So we can do it with a case, we can do it with a rest. Okay, so Gleam language tour, cool. Contents, basics, lists. Okay. So we can do this, that's cool. We can put things at the end, but I think that if we do this rest syntax, I think it has to be at the end. They're immutable single linked lists. So it's rare to write algorithms that index into sequences in Gleam, but when they are written, a list is not the right choice of data structure. So what do we think? Well, I mean, we are using lists. A list is what's asked for. So we know it's got to be a list. Reversing this is supposed to be easy, right? Okay, let me think. I might have to write it down for myself. We know we can take the first element off. Oh, wait a minute. I think we need to handle the case where there's just one element in there. Is that something we can do? That is something we can do, I believe. Okay, I'm just gonna look. So I believe we can go... There can be a case where there's first element and then not anything else. But in that case, again, I guess we just want to do first element, because there's nothing to reverse. Okay, fine. All right, so what if there are exactly two elements? this seems super questionable already. But in this case, we know we just want to do second element and then first element. So is that our real base case? Does that make sense as a real base case? I don't know. So we can reverse those there. And then if there are more than two elements, this isn't it at all. This is not it at all. I think we need to do iteration. So let me look at flow control and list recursion. Flow control, recursion, tail call, alternative patterns. Oh man, oh man. Yeah, so we're taking each item off of the front, and then we want each item that we take off of the front to become the front. Okay. I think there are two parts to this. Can we do a case and then another case? Shoot. Where was that one it just showed? I'm weirded out that, like, man, I don't even know what I'm doing. It showed like a total or something, right? Alternative patterns. Oh man, okay. Man, I know this is so easy once you know how to do it. I guess that's why I'm doing it, so that I'll know from now on. Okay, let me think. So that I'll know from now on how to do it. Okay, so if we are trying to do whichever one of these, so let's say that we are trying to do a length. If we're trying to do a length, then we need to return. So it's going to be a case. The empty, we are going to do 0. First element, we will do 1. First element, rest, we will do 1 plus length rest, right? So that one's straightforward. Okay. Do I even need this middle one? Will this rest become an empty list if there's nothing there? I think it will, actually. Let's get rid of that. Okay, so let's at least try that test. Okay, so syntax error, wasn't expecting elements after this. Okay, so let's go back and fix that. On 15? Oh. Oh, list. Okay, how is the case expression again? You do case. Okay, that's on 42. Let's fix it on 42. And on 46. Let me get rid of this one because I don't know how to do this one yet. Okay, ran 22, 20 failed. All right. Okay, this is a lot of output. I think I really only wanted to test the ones that I had done already, but okay. The one I did was just length, the easiest one. Hmm. Okay, so in length, I have this unused on 15. Hmm. Okay, still 22 and 20 failed. Okay, let's see which other one I think I might know how to do. Filter. So case list. And then here, it's again going to be a case, I believe. And this time it's case, let's say E, rest. And so then it's case E. No, it's case function E, I guess. And then we just do true. Let's see. Okay, true with a big T. So if it's true, then we are going to return E filter rest, right? And if it's false, then it will just be filter rest. Inexhaustive patterns. Okay, so then in the case where it is empty, we just do that. Incorrect arity. Expected 2 arguments got 1. So we'll put the function back in. Okay, let's see if that passes anymore. It says just 18 failed. Okay, let's keep going. All right, concat. Filter seemed like an easy one. I think map should be quite an easy one, right? So in this case, we'll just do case list, and it will be rest, and then it will be function dot map rest. And then this other case will just be nothing. And then that's it. What does this say? Oh, and we have to pass the function back in. Okay, so then fold L might be pretty easy as well. Actually, I'm not sure. Okay, so fold L and fold R. So if the limitation, because we're working with singly linked lists, so the limitation is that we only want to take things off the front. What does that mean for our fold L and our fold R? Does that mean the fold L is much easier? So if we take everything off the front, then yeah, it might be. I'm not sure. Let's just try it. So fold L will take an over list. Wait, over from with. I actually don't understand why these have like two names like this. Over list, from initial, and with function. Let me see if that's explained here. I guess it must be explained probably somewhere. So these just have one name each. Let's see if one of these is going to have two names. Labeled arguments? Okay, labeled arguments. So when functions take several arguments, it can be difficult to remember what the arguments are and what order they are expected in, okay? To help with this, Gleam supports labeled arguments where function arguments are given an external label in addition to their internal name. These labels are written before the argument name in the function definition. Oh my gosh. Well, that's crazy. All right, so that means what? When labeled arguments are used, the order of the arguments does not matter, but all unlabeled arguments must come before labeled arguments. There is no performance cost to using labeled arguments. It does not allocate a dictionary or perform any other runtime work. Labels are optional when calling a function. It is up to the programmer to decide what is clearest in their code. Okay, so that's what we've got. So, all right, so we're going to go case list. And so again, it will be rest, and we're going to put in a function. Let's see. So function BA. So we'll go function, and we'll pass, wait. B and A get passed into the function. Is A the list? Actually, I'm not even positive. Let's see how it's explained. Fold L, given a function, a list, and an initial accumulator, fold reduce each item into the accumulator from the left. Yeah, this function just says it takes B and A. Is A the accumulator? I'm actually not even sure. Interesting. Well, let's see. Let's try it. Okay, so the from initial is B, and then this takes a B, and it returns a B. So that B has got to be the accumulator, and that A has got to be this, I think? No, hold on. So we pass in an accumulator and an element. Okay. So we have to use... Oh. So I think we pass in maybe E, and then pass in a function rest. No. We fold L on the rest. No. We fold L. Okay, this is where the difference between left and right. Oh gosh, oh gosh. We fold L on the rest, and then we pass in function BE, I think, and then we pass in function again. Okay, so then if it's empty, we just return B. So I don't think B goes in here. This should be, I don't know actually. So if it's nothing, we put B back in. So that we shouldn't put B in here. That's crazy. Oh no, I don't know what we put in here. And then if it's fold R, it's similar. So case list E rest. Okay, sure. And then in this one, we do function. Oh, this, no, man. Alfred STID, thanks for chatting. Let's see, what is this? Tolof Monk. How's it going, Alfred? Okay, so the function just takes two items. And so the question is, what goes in there? Okay, so I think, oh gosh. I think when it's empty, it has to be B probably either way. I would think. And then here, rest has to be passed in. Nothing else would make sense. Or no. Function has to take E and then fold R on rest, and then what goes in here? Man, I am really struggling. It's absolutely crazy. Okay, I'm gonna try and do it out. Actually, let me try and do it out. Let me just type it in here somewhere. Okay, so we start off, we have nothing. All right, so then we have a case where we just have one thing, which is the last thing in the list. All right, and then what do we do when we have two things? So we have X and Y in here. So that means we need to pass both X and Y. No. There's an initial accumulator. So when we have just one item in here, then we need to pass that one last item into the function with the initial accumulator. So let's see if that's a case. So if we have a case where it's just E, and that's the last thing in there, then we know that one's easy. We just take the function and pass in E and B. Okay. If there's nothing, we just do B. But this is the real base case. There's one thing in there, so we pass in E and B. And is that again the same here? I think so. Okay, so B definitely should not be used here. That's crazy. So in the case where it's the rest, it might be just this, or it might be more, but that doesn't really matter. So we're going to call fold L. We're going to pass in the rest. We are going to call... No. I guess we do have to call the function on E and... Okay. Let's delete this. We're going to call the function on E and fold L, the rest. What gets passed in here is still B. That will always be B. And the function. Okay, that's simple. Okay. But then how is it different when we do fold R? I think one of those might work and the other won't. I was not expecting this. Okay. 44. Okay, the name B is not in scope here. That's on 52 and 53. Oh, B is not in scope here? Oh, it's initial. Initial is what it is. Okay. I was using B that whole time, but that was crazy. Okay, so it says type mismatch. So we tried to pass in fold R, but it didn't. So it was expected type A, found type B. Okay. So I think I just reverse these. Okay, it says type mismatch. We passed in A and expected B again. I just reversed that one as well. That's on 51. Okay. Yeah. Okay. Ran 22 tests, 11 failed. Okay, so I don't even know which one failed. Fold L or fold R? Fold from the left failed. So did fold from the right pass? Okay. Okay, this is crazy. I'm gonna try some more of these until few are. So I still don't know how to do reverse. Let me think. So for reverse, like I think okay, so on this one, so if there's nothing in there, then we just do nothing. Simple enough. If there's one thing in there, we just pass it back. If there are two things in here, then we reverse the order. And that's probably the real base case, maybe, for most of these. I think my thinking on this is very wrong. Okay, so is it better if we do like that? Okay, so that would work in some case, I guess. But then the real case is if it's more, then in that case, I feel like we reverse and then add to the end. So is append adds to the end? It is, right? So we would use the append function. Okay, so that means I got to figure out how to make the append function work. Oh, except no, the append function are appending two lists, actually. Okay. So for this one, I mean, so you would think just reverse it, but there's no way, right? Because we can't just throw something on the end like that. It won't allow it. It's saying reverse it when you're done, right? But we are trying to figure out how to reverse it without using somebody else's function. All right, so we take things off. It's effectively a stack, right? So we're unstacking from one stack and then stacking back onto the other. I would think. Okay, where's assignment? I think we should have something like assignment. Maybe assignments. Yeah, let's take a look. Yes. Yes, this is what we need to do. So in a case statement, I think, can we put a block? I want to say we should be able to. Let's see what it says. Case expression. So it doesn't necessarily show it as a block, but let's just try it. Okay, so this should be, I think, this should be a block. And so first we say let reversed equal reverse rest. Okay, is that how the assignment kind of was? Yeah, I believe so. So let reverse equal reverse rest. And then we have to put that, and then we have to put E at the end of that, I guess. It kind of discourages you. Okay, so list. So counting the length of a list or getting elements from other positions in the list is expensive and rarely done. It is rare to write algorithms that index into sequences in Gleam, but when they are written, a list is not the right choice of data structure. Ooh, I'm going to be so much better off once I just know how to do this. This is for sure stuff that I need to be knowing how to do. So these are functions. Okay. Man, oh man. What else is there besides the tour? Discord server. Oh man. Okay. No loops. All right, so we know we want to go, basically what we want to do is we want to say while there is anything in the list, while list not empty, we want to take the thing off of the list, take first off list, right? And put it on new list. And that's really all there is to reversing. And I just now have to think how to do it if we're using recursion and not a loop. So I think it's still just as simple. I think my mind is just very dumb on this. Yeah, so I think that doesn't really make sense. Um, this probably doesn't even really make sense. These probably don't make sense. It's really just this. So all we want to do is go reverse rest, and then somehow E is supposed to be at the end of that. Oh no. Oh no. I am a complete mess. I guess I need a helper function is what I need. Do I? Let's see. Yeah, I think a helper function is what I need. I wasn't even thinking of doing that, but honestly, that just makes sense. So functions. Okay, yeah, let's put a helper in here. So function reverse helper, which takes a list A, and let's just call it like old list A, new list A, and again returns list A. I hope this isn't just as poorly thought out as everything else. Okay, so then we'll do case list and it will be, or no, it'll be case old. Okay, so E rest, and then it will be reverse helper, and rest will go in here as old, and new will be E new. Oh my gosh. Yeah, that's totally it. That's totally it, isn't it? Is it? No, it's not. What am I saying? No, E, no, E, should it go on the front of new? Yeah, I believe it should. Yeah. Okay, so then the base case will just return new. And then we just go reverse helper list empty list. I think that's it. I think it's literally as simple as that. Syntax error. Only module level functions can be named. Okay, let's just move it into, or out of the nesting. Okay, only 8 failed. Yeah, so that is it. Man, I was so uptight in my thinking on that. Oh my gosh. Oh my gosh. So simple. Like, yeah, that is weird. Like, for some reason, like, I guess my imagination was like just disallowing the use of a helper function, even though I've used helper functions tons of times in recursion. Well, I'm glad I'm past that, because that was really weird. Okay, so I guess that one is good. Okay, so now we should be able to append, I guess. So for append, I think we have to probably have a helper for this one as well, maybe, because we're going to have to reverse the second list. No, wait. Which one are we going to have to reverse? We're going to have to reverse the first list in order to put all the pieces onto the second. So if that's the case, then we do need a helper because we only want to reverse it once. So it'll be function append helper, which will take a first list A and a second list A. But let's specify that this is reversed so that we know that we don't have to reverse it again. And it will return a list A. Okay, so then case first reversed. So here we are going to put append helper, and rest is going to go here, and here we are going to put E second, like that. Okay, and then in this next case, we're going to put, we're just going to return second, right? I think so. Okay, so then here, we just go append helper, reverse first, second. Only 4 failed. We're getting there. We're getting there. Oh man. Oh man. I can't believe how long it took me to think of that reverse. I just need to practice more. That's why I'm practicing now. All right, so concat. So in concat, we have a list of lists. So I feel like when we concat, we are just going to end up appending. So it's going to be case lists. And so again, we're going to have E rest, I guess. Why not? And then we are going to append E concat rest. Yeah. Okay, so then in the case where there is nothing, no. Can we do a case where it's just X and Y? And then in that case, no, that doesn't make sense. We just need the empty case. So the empty case will be just that. I think. Yeah, I mean, so recursion makes a lot of these things so easy. Okay, there's only one failed, and that is fold left, right? Okay, last one. Okay. So 3 failed. So did it still fail the same one from before? Folds reduces the given list from the left with a function direction, dependent function applied. Okay. So if we just copy that, then there's only one that fails. Yeah, there's only one that fails. All right, so then how do we do it from the reverse direction? Let's see. I am thinking that it's probably just going to be a matter of reversing it. Now that the reverse is implemented, then we can just do that. So we'll fold our reverse, and then we'll pass in list, initial, and function. I think that's it. Oh, no? Okay, I just did it wrong. It should be reverse list. Okay. Wow, that was an interesting journey for me, honestly. I just spent a long time on that too, but I'm super happy about it because I've been needing to practice. They're essentially like functional programming concepts, I guess, where you use a lot of linked lists instead of arrays, and you don't use loops, you use recursion, and I'm cool with it. So let's submit. I've been needing to practice such things, obviously, because if I had been in practice, I would have finished that a lot more quickly. Oh, it's actually listed as a medium, so that makes me feel a little better, I guess. I don't know. Actually, no, I do feel good about it regardless. All right, so let's mark as complete, confirm. Okay, cool. Let's close these out and see what's next. All right. Okay, so we did list ops in Gleam. The next one is Swift. Okay, we'll see how this goes. So join the Swift track. Practice mode, local. Okay, Swift tooling. All right, so we are on. I'm assuming that it's not installed. I don't think it would be. Install Swift, Linux, Ubuntu. I just said what this was, right? LSB release. '22. Okay, 2204. Docker image? Is this what we want? I mean, it sounds fine to me. No, because it'll want to run the Swift command. So tarball. Install required dependencies. Okay, let's hit it. Sure, let's go. Very interesting. Okay, cool. And then we are going to download the binary release. Okay. Oh no. All right, that's not too bad. I don't think. I do find it to be a mental workout to be sort of like jumping from one programming language to another, especially considering many of these are programming languages I've never tried. And, you know, frankly, even among the ones like C sharp is one that I should be pretty familiar with, but I mean, I did it at work for 2 years, C sharp, but that was 3 years ago the last time, so I'm just forgetful with time. I'm getting old. I'm a middle-aged person, so yeah. But it's fun. I think it's a good mental workout to do all these different programming languages. Like in kind of I'm trying to do them in rapid succession as best I can. I'm not doing them super quickly, but I'm doing them as quickly as I can kind of manage. Okay, so we downloaded the tar.gz. And so let's extract the archive. Sure. Okay, let's come over here. And we'll go tar xzf. And we'll go downloads / swift -6. Yeah, let's see what that does for us. Okay. So do we get the file? Yeah, Swift. Okay. So then we are going to create a... Oh, interesting. Okay. User directory. Okay, interesting. So now we have to find the bin in there. So user. Okay. So we're going to export path equals, and it's going to be home Josh exercism clean list ops Swift etc user bin, right? Yeah. Okay. And so now it says, okay, so then let's put this into my ZSHRC. Nope, 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 nope. Okay, yeah, let's put this in here somewhere. Yeah. Okay, so now we can use Swift. Let's get the hello world. I think this is such a smart idea. The way they they've really like facilitated just going through these languages so quickly, right? Because they provide like all the information you need, and this exorcism tool is awesome. I think they've done an incredible, incredible job with this stuff. Okay, so anyway. Swift. Hello world. There we are. Okay. Let's try the tests. It says running test via Swift test. Let's do it. Very exciting. And it says test run with 0 tests. Okay, let's look into the tests. All right, so there's an X here and an X here. Wait. So XC, that's for Xcode test, I think, right? Xcode test, probably. And it says assert equal, and it says hello, and it says hello world. But I don't think it ran it, right? Okay, let's go out. Okay, so it says we're supposed to do Swift test. 0 tests. That's messed up, man. Okay, so what is the problem? All right. Run the command in the exercises directory. Okay, so does it tell us why there... So debug xc test, hello world tests, hello world tests, test hello. Wait, this is confusing. So this says test run with 0 tests passed, but it says that it failed here. So what's that about? Okay, well, I guess I'm just reading it wrong. I don't like to see that green check mark and 0 tests. Like, what the heck? Okay, so it says failed here, and I just wasn't looking there. I was only looking at the bottom line. Usually you only have to look at the bottom line. I don't know. All right, so... Oh, I don't know. I don't know what that is. Okay. So... Let's go into sources, or no, let's vim sources slash hello world Swift. Okay, sure. All right, now let's change it. And now let's run the test and see if it's different. Okay, so executed 1 test. Okay. I can read this more clearly now. Executed 1 test with 1 failure. It said it 3 times, and I only looked at the bottom line and I was confused. All right, so then 0 failures, so that's good. I think. Let's submit. Or actually, let's exercism test. It should be the same exact thing. And then let's exercism submit. /source. Hello. Yeah? Okay, let's take a look. Okay, processing. Oh, and check it out. Well done. Did you know in Swift, even a simple function like this can be written simpler by using an implicit return? Some people, like Paul Hegarty, prefer to write one-line functions in one line like this. How awesome Swift is. Well, I mean, sure, yeah, it seems very awesome. All right, so anyway, so it says passed, so we'll mark that as complete. Okay, so I'll close out these ones, and we are gonna go to list ops again. Okay, so this one was a head scratcher for me, I must admit. But now that I've done it once in Gleam, I guess it should be easier here. I will say the Gleam syntax looked a lot like Elixir syntax to me. I'm not familiar enough with either one to really be able to tell the nuanced differences, but they seemed pretty similar to me. All right. So let's go to Swift or no, hold on. List ops, that's what we want. Okay. So, vim sources, list ops Swift. Okay. Oh gosh. Solution goes in sources. Man, no boilerplate this time. Ah, sad. Okay. Yikes. Okay. So are all of these active? I think they are. Okay, so I think we have to create like a list ops class that has these methods on it, I believe, something like that. Let's see what it says in the README. Okay, let's take a look at what we had for Hello World. Okay, so it just said func hello string return hello world. Okay, so now if I swift test here, is it going to show me all the failures? Presumably. Module list ops has no member named reverse. Okay. So let's add reverse just like this. So it's going to be func reverse. It's going to take a list. Are they all supposed to be int lists in this case? Is that what I'm seeing? That doesn't seem right. I think it's supposed to, they're generic lists. Okay, let me look at Swift generic. Swift generics. Okay. Right, so swap to int, swap to whatever. Okay, so we just put it like this. Okay, let's try it like that. Okay, so I'm gonna put func, and I'm gonna put reverse. I'm gonna put t, and then I am going to put, let's see, why do they have the underscores there? I did a Swift tutorial, and I know they told me what these underscores were for, and I cannot think what they are for right now. Okay, I want it just more like this. Okay, so reverse, and it's going to be a list of t. So collection type. Okay. Just like that, probably, right? Oh, no, it returns t. Yeah, okay. So I don't think I want to do it recursively like I did last time. I think I just want to say, I think I want to use a 3-clause for loop, actually. Control flow, for loop. Okay, so I'm going to put... Wait, where's assignment? Oh, man. The basics. No, assignment. Okay. So let's put... Should it be a var? Yeah, it should be a var. So var result equals... Do I have to give it a type hint since this is empty? I probably might, but let's come back to that. All right, so then I'm gonna go for, and again, oh man. Okay, so for E in list, and then do we have like a spread or something? Mutability of collections? Oh, creating an empty array. Yeah? Okay, cool. Very nice, very nice. Okay, so we can use append, but we're not supposed to because that is somebody else's function, right? That's an existing function, so let's not do that. Okay, so we can add things together. Yeah. So I'm allowing that. Like using an addition operator, like is it really so different from using a function? Probably not, but it's technically not a function. It's an operator, and I'm going to use it because that's going to make this easier. Okay, so result equals, or actually I'm just even going to say result plus equals E. Return or actually we can even just put result, right? Okay, is that it? Is that it? That's it. I think that's it. Let's see what that does for us. Swift test. So did we test the reverse function? I can't tell yet. So building for debugging. Type any. Okay, so this is append. We don't have append. And it seems like a lot. Okay, I don't think it's in there. So I think that probably means that reverse actually passed, which would be great. So let's do the next one. So I think the next one, let's just do length. Okay, so I'm going to say func length. And I guess I still need it genericized. I don't know. Let's see. Swift test. All right, so what's it say about length? So length, yeah, I think is not being, wait. Missing argument label list in call. Oh, shoot. So the argument labels. So person string. Okay, the underscore is for a positional argument. Man, yeah, I remember that was in the Swift tutorial. I did a Swift tutorial. Did I remember that you needed an underscore for a positional argument? No, I was even like, oh, what do you need an underscore for? Okay, so let's make this a positional argument, optional. Okay, so is that better? I think so. Okay, let's try append next. Append. Okay, so then for this one, we just say for E in list 2, list 1 plus equals E, return list 1. Okay. So that's not mutable. So whatever, I'll just say var result T equals this for E in list 1, result plus equals E, result. Result. There's some kind of warning. Immutable value E was never used. Oh, okay. That's on length. Let's do that. Okay. Let's do concat next. So this is more like this. And we return. So they've called it concat, but it's more like what I would call flatten, probably. But whatever, it works. I would call it flatten, I think. Okay, so for this one, we want to say probably var result is this for list in lists, for E in list, result plus equals. No, we don't need to do that. Let's just say result plus equals list, actually. Return results. Yeah? Okay, still a ton of text coming out of there, but that's cool. Let's do... Oh, concat cannot convert value of type int to expected argument type any. Oh, I screwed that up. So what did they pass? List ops concat int. Oh, shoot. So it's supposed to be concat empty list. Okay, so I definitely did not do concat correctly. So it's supposed to be some kind of like var args. Multiple parameters without return values, multiple return values with an implicit return. Okay. Argument labels, omitting, default parameter. Okay, here we go. Variadic, variadic. Okay. So I see. So it should not be this. It should be variadic. Will that work? Yeah, I think that is better. Let's do filter next. Okay, so we're going to take a list, which is T, and then we're going to take a predicate, which is, okay, so it will be function, and I will call it func, which takes some E, I guess, which is of type T, and returns a bool, right? And then this itself returns this. Okay. So then let's say a result for E in list if fn E result plus equals, right? Return result. About like that. Let's see what it says. So this is filter. Okay, so expected identifier in function declaration. Okay, I'm missing a colon there, I think. Oh, much better. Okay, so expected parameter type. Okay, so that's, so if a parameter type is a function, function types, okay, using function types. Oh, I put func in there, but that was not wanted. I was just a guess at what was supposed to be happening. So in fact, we don't want any of that. We just want that. I think. Yeah, I think that's better. Okay, let's do map next. Okay, so map can probably take two types, right? Because we have a function which takes a t and returns a u, and this returns a list of u. I'm not sure if this is right. But yeah, basically. So then result is a list of u for E in list. Result plus equals fn return result. Yeah. Okay. Yeah, I think that works. All right, let's do fold left. All right. I think it's TU again, probably. We're going to take a list like this. We are going to take a initial, I guess, which is a U. And then we will take a function, which takes a T and a U and returns a U. And then the function itself returns a U. Okay, so var result equals initial for E in list. Result equals fn E result return result. I don't know if that's right. Let me just see. Fold left. Extraneous argument labels accumulated combine in a call. Okay. So accumulated and combine are the names of the. Let's fix that. Wait. I probably need to look at that. Okay, let me fix that. Okay, extraneous. So, okay, we called fold left extraneous argument labels. Fold left. Extraneous argument labels. That surprises me. I thought that'd be okay. Fold left. We pass in a list, an initial, a function. Okay, let's look again. So do we have to get rid of this? For some reason, I actually thought that you were allowed to go either way. I'm not sure if that'll fix anything. Oh, no, apparently it does. Okay, so that just leaves fold right. Okay, amazing. All right. So again, I'm just gonna reverse, I think. So I'm gonna say func fold right tu list t accumulated u combine tu u, and we are gonna say return fold left reverse list accumulated combine. Yeah. Okay. I was wondering if it was going to require that. It's fine. Is that it? Exited with unexpected signal code 4. Oh no. How did the program crashed? Illegal instruction? Oh, I hate it. Oh no. Oh no, what have I done? Okay, I'm not gonna do that. I don't know what happened there, but it was not good, baby. Actually, let me just say, so var result equals reverse list. And then result equals fold left result accumulated. Something about this makes me nervous. Combine. Well, what makes me nervous is the fact that it crashed on me that time. Okay, so let's see. Okay. Cannot convert return expression of type. Okay, okay. Crashed again. That's crazy. How can this be? I don't know what to think. Division by 0? Oh, well, I think it said that before and I just didn't look at it. Is it division by 0 here as well? Yeah, right here. Okay, division by 0. Huh. And is that... Oh, that's crazy. So that's in the tests, I guess? They do, like, some division here somewhere? Yeah, they do division. And apparently I divided by 0. Shoot. Well, I didn't mean to. So I wonder if when I reversed it, it was really wrong. Huh. Yeah, I'm not sure why I got divided by 0. Something's clearly very wrong. Okay. Ugh. Okay, let me just not do this. Let me instead go result equals accumulated. for E in list I don't know. I feel like the way I want to do it is by actually reversing. But the reverse must not be working correctly, right? So let me just... Missing return in global function expected to return. Is null a thing? Non-void function should return a value. What? No. Still? Okay, so division by 0. And it was... Test fold left non-empty list division. Okay, so now we should have no divide by 0, I think. Okay. Build complete. Okay, so where does it show the tests failed? Okay, 6 failures. Okay, there we go. All right, so I don't like reading this output. It looks goofy, but okay, where are the failures? Okay, so here's one. So fold left, so we've got failures in fold left and fold right. Okay. Reverse non-empty list. Okay, 1357, 7531. Okay, so it didn't actually reverse. Okay, let's fix reverse then. For E in list result equals E plus result, right? So I never actually reversed that one. 5 failures. Okay, so that eliminated 1 failure. So I'm looking at failures on fold left, fold left. Okay, so they're all the folds. Okay, good. Okay, so let's try fixing one of the folds. We don't want any divide by 0. That'd be crazy. So I would say var result equals accumulated for E in list result equals combine E result return result. Okay, that still seems pretty okay to me, but apparently we get a divide by 0. So that's crazy. That seems a little crazy, because there's no 0 in there, right? So I'm putting a 0 in where it sure doesn't belong. So we have 2, and we have 5, and accumulated is 5. Oh, wait. It said it should have been 0? Oh no, that's crazy. Huh. Okay. So we're supposed to start with 5. We're supposed to divide by 2, which I guess gives us 2, and then divide by 5, which I guess gives us 0. All right. I guess that's okay. I think. Okay. I think I combined them in the wrong order. Okay, so now only 3 fail, and they are fold right. Okay. Something about this seems a little crazy, but okay. So here we are going to return fold left on reverse list accumulated, combine, combine. Okay, so this is supposed to be UT. Decided, I guess. Okay, 2 failures. Fold right. Okay, it was supposed to say exorcism, and I reversed it. Huh. Okay, so let's look. So it's one of the fold rights. We're supposed to get fold right, add string, exorcism, and it started with a bang and combine, but apparently we reversed it, which seems crazy because that means that maybe we weren't supposed to do this. I've definitely screwed something up. Okay, so now it says 2 failures. Oh my gosh. Okay, so okay. So I'm gonna say result equals accumulated again. Then I'm gonna say for E in reverse list. Result equals combine. Result E. Return result. It's got to be the exact same thing, right? I think so. Yeah, same failures. Oh, okay. Wow, okay. So on this one, so we're supposed to fold right, 2 failures. Oh, man. Okay, fold right. Something seems suspicious. So, was there no... Hold on. Was there no test for fold left of add a... So, fold right add string, but there's no fold left add string, right? Okay. So, accumulated is supposed to go at the end, but the rest are supposed to go into the order that they were put in. I think. And then we got divide by 0 on fold right non-empty list division. Huh. I really have not I really have not understood what I'm actually supposed to be doing. So, we do that. Zero failures. Okay, so why did I not do it that way in the first place? So we reverse. We just reverse both things. So why did I not do it that way in the first place? I don't know. Okay, so we reverse it, and then when we go to combine, we combine in the reverse order compared to fold left. Well, I'm gonna move on. I'm gonna move on with my life. So, to be honest, I think I haven't understood that, and I'm gonna need to revisit it. Lucky for me, we're about to revisit it, I think, unless Swift was the last one. No, Swift was not the last one. Okay. Oh, okay, so this one's... Oh, interesting. So this one is marked easy. Gleam was marked medium. So they're different. That's interesting. Okay, cool. So let's go back, and then we find that this is marked off, and now we have to do it in SML. Interesting. All right, so let's join the track. But I'm going to take a quick break before I start here. I'm going to be right back in probably 5 minutes. Okay, back. Let's see. I think this might be the last one for today, honestly. Um, yeah, I'm okay with that. If this is the last one for today, I'm okay with that. All right, so SML, let's take a look. So continue local, let's look at the tooling, baby. Okay, so do we want to install from, okay, so polyml, we can install from source. Is that the best way to go? Sure, let's do it. Okay, let's clone. Build from source is going to be kind of slow, isn't it? Let's see if there's a brew option. Just in case it's faster. This, yeah, there's no doubt. Brew is going to be way faster than build from source. Probably. Yeah, way faster. Yeah, let's just do that. Okay. Okay, let's do our hello world. It says, okay, cool. I love this. This looks great. Expected hello world, got goodbye marks. Love it. Very easy. So let's look into our hello world file. And I mean, yeah, this is simple enough. Okay. Not that. We're gonna hello world. No, no. This. Okay. Okay, so that was quick. I think this one might be the easiest yet today. No, the Julia one was easy earlier today. Okay, so mark this. Okay, so now we're gonna come into list ops. We'll see how this goes. It could be interesting. I am guessing that it might be kind of similar to what we did in Gleam, but we'll see. Okay, so we can try running test, and it says, okay, not implemented, love it. Let's see what we've got in our list ops file. Okay, cool, awesome. Love to see it. Okay, so I'm gonna just try and start these off similar to what I had in Gleam. So I'll have a reverse helper, which takes a old int list and a new int list, returns an int list, and equals. Okay, so then in standard ML, do we use a case syntax? I think it is something like that, but I haven't ever tried it before. So standard ML programming. This looks like a valuable resource. Maybe not the super easiest way, but let's see. So let, interesting. Yeah, you would know this language well if you read this whole book, and I'm not trying to read this whole book right now. I'm just trying to get this one problem done. Oh no. Okay, so PolyML homepage. Okay, standard ML docs. Maybe? Okay, this looks like it might be a little better. Maybe? Oh, I'm nervous. Okay. Standard ML family GitHub project. Okay. We've got definitions. Good. That might be the place to go. Oh, this is another big one, huh? Another big book. Okay. Let's see. Standard ML getting started. Okay, so this is, oh wait, bad link. Okay, so this is what I saw before. Okay, so yeah, reading this would for sure get us to where we need to be, I think. So do we use, man, I feel like it must be some kind of matching or matching syntax or case syntax, something like that. Okay. Tutorial. Okay. Getting started. Syntax cheat sheet. Comparison. Patterns and case expressions. Ah, here we go. Yes, this looks fine. So, oh gosh. Okay, so this, oops, should be reverse helper list nothing. Maybe? I don't know. And then this should be like these kinds of cases. So if, So int list with 2 colons. So does with the 2 colons, are we going to take this off the front? Is that what's going to happen? Let's go to the first. Okay, so int list, string list, int star int list. Okay. List construction. Okay, so that adds the 1 onto the front there. And then list combination. And that's an operator. Okay, I'll use that for sure. Okay, so the double colon, we see quite a few places. Okay. And then in the when we have a pattern with the double colon. Okay. So I think this means that we're going to take. No, we have to match on old, right? The fun reserved word allows self-reference by default. Fun length Okay, so then we do the pattern. Okay. I am a little confused. More than a little, probably. Okay, let me delete this one and delete this one. And in fact, let me just go back. Okay, let me try append, right? Since there's an append operator, I'm just going to use an append operator for this one. So this will be list1 append. Do I remember what it was? I think it might have been yeah. Okay, so 3 passed if we do that. Okay. Okay, so length should be a simple one, I think. But again, fun. So x, y, x plus y, but then okay. But okay, so it should be more like this. So length ns, but I'm gonna put that, and then I'm gonna put 0, and then here it's gonna be type, and then it's gonna say length again. I'm pretty much copying from here, aren't I? Yeah, pretty much. Okay, I'm okay with that, I guess. I mean, if it's right there in what I'm looking at. NS is what they had before, right? Okay, 5 passed. Okay, okay. I love how terse and gorgeous this syntax is. It would take me quite a while to actually get accustomed to it, but I'm in love with how cool it looks. All right, so let's try filter. So it takes function, int bool list, int list. Interesting. So for reverse, it might be something like that. And then here, let me see how it looks in the test. So when they do, like when they do, which one do I want to look at? Okay, so we should use parentheses, I think, right? Yeah. And probably with a comma. Is that how it was here? Yes, with a comma. Okay, cool. So then, this next case, and let's stop that. So this next case is reverse list int list and old int list. So let's call this one new. And then that equals, so now we put, yeah, like that. So we take something off the old and we put it onto the new. So now we say reverse e new old. Okay. And then if we reverse and that's empty, then we just send new back. So it says type of clause does not match the type of previous clauses. Okay, so it should be in a helper, I guess. So fun reverse helper, and it takes new int list e old int list equals reverse helper e new old. Okay. And then here we say reverse helper new int list and then here we only have the one case, and that is like this. Okay, 6 passed. And 1 failed. So the failure is what? I'm not sure yet. Let's just keep going. Okay, let's look at concat. So for concat, we're going to have int list, which gives back an int list. Okay. So if we concat nothing, then that's it. If we concat so here we append, and we put in E and concat X. Yeah? Value or constructor append has not been declared. Okay, let's see what I did wrong. Oh, append is down here. So do I have to move it up? That's fine. Let's see if that's really it. Oh yeah, 8 passed. Okay, cool. All right. Okay, let's do filter. Okay, so for filter, we have a function and some list. So let's say in this case, There's nothing there. And so then there's nothing there either. Then in this case, we'll still have a function, int bool. So then do I need a helper for this one? Maybe. Maybe. So fun filter helper, which takes in a b bool, or let's say it's a true bool, and what's the other thing? And an int, I guess. Yeah, maybe something like that. And then out of here will come, I guess, an int list. Probably. And so that will be like this. And then in the other case, false bool int list equals like that. Okay, so then here, whoops, ex int list equals filter helper function e and this is going to be append filter x. Yeah, I think it's like that. Constructor E has not, okay, so it's on 13, constructor E. Oh, this should be a colon. Can't leave that out, baby. On 17, constructor in a pattern was not an identifier. Okay, I think I made a similar mistake. Yeah. There's, I think, another one. Type of function does not match type of recursive application. Okay. Yeah, so that's a silly mistake. So can't unify int list to int bool x int list. And this is on 16. Let's see. Oh, okay. I'm not quite sure what's wrong there. Let me read it again. So type of function does not match type of recursive application. Filter int bool variable filter int list to int list. Can't unify int list to int to bool. Found near filter int bool. I don't see it yet, but let's see. Shoot. Okay, this is skill issue for sure. Okay, type of function, and it's telling me exactly what to do. I just don't know how yet. Okay. Does not match type of recursive application. So we filter something something int to bool something something, sure. And int list, yep, like this. Okay. Int list equals append all this. But then what's this? Int to bool. Okay, so this part, this doesn't seem right. Hold on. So we try to do filter helper, which is supposed to be bool and int. Seems like that part should be okay, maybe? Function, okay, that's all the same. I think this is okay. Append. Okay, I think I've misunderstood. Like I'm wanting to use this function that comes in, but it seems that I can't do that. So let's see what it says about maybe passing a function into a function. It seems like it might not work there the way that I thought or imagined it might. Okay, int string charbool real unit. Okay. It's definitely like a skinny arrow. Okay, comparison. Wait. Order. Okay, so here. Okay, so it's a. I. No. Shoot. So we know the type of the function is that it should be int to bool. Okay. Function type and function application. Yeah, this is what I want to know about, I think. Okay. Shoot. Okay. Oh man. Higher order functions. Yeah. Okay. Okay. So for one thing, okay, I made this mistake. I made the same mistake earlier. That actually might be okay. Oh, not Swift test. Exercism test. Okay, does that change it? No. It's clearly much simpler. I mean, it's going to be very, very simple. In fact, we can look and cheat here. All we have to do, if we just understand how this works, all we have to do is just apply, oh wait, oh no, if then else. Oh shoot. Okay, let's not look at it anymore, but let's use if then else, which they mentioned. Oops. If then else. Let's not do append either. Okay, so this is fine. But then in this case, we have the e and the x, and we want to say if, and we want to apply the function to the e. Then we will say this, maybe. Else, we'll just do filter x. Okay. So it says type function. Oh, okay, still saying the same thing on 13 now. Okay. Can't unify int list to int to bool x int list. Okay, so still not really getting it, obviously, but if function e at filter x, else filter x. Okay, can't unify int list to int to bool. Okay, so it's still looking at it like it's a tuple, I think. The mistake might be something simpler than what I've realized. Oh, of course. You know what? Yeah, this is simpler. As soon as I said that, like, oh yeah, this is simple. I'm not passing the function in. That's silly. Oh my gosh. Oh my gosh. Yeah, I wasn't... It was telling me exactly what was wrong, and I just wasn't understanding it for like 20 minutes. Okay. Ah, it happens, I guess. It's just not having ever done standard ML before. But, alright, so let's see what's next. So, map. Okay. Okay, I'm gonna try to make this cool. So, if there's nothing here, then nothing has to come out. That's the base case, or just the obvious. And then in this case, we still bring that in, and then we have like some two parts, right? Like we have the first item and we have everything else. Love it. It makes total sense. And we're still gonna do this. And now we are gonna say, um, function e at map function x. I mean, it should be just as simple as that, right? 12 passed. Okay, let's look at our fold L. Okay, I think this is going to confuse me. I'm getting close to being done for the night. I was way faster yesterday because they were just easier problems. All right, so fold L. So again, we'll have a base case where there's nothing in there. And in that case, initial is what comes out. Cool. Then we have a case fold L function int to int initial int list, and an int comes out. And what we do here is we put in function called upon, oh no. Okay, function called upon E and fold L of function initial and X. And I mean, really, that's, I think, basically it. Ooh, yeah, okay, we're getting closer. Okay, so then for fold R, this one I'm going to try to keep simple. I believe we should just be able to do fold L function initial reverse list. Maybe? Okay, so 17 passed. Okay, we're getting close. All right, so direction-dependent function applied to non-empty list. Okay, so something didn't work. Okay, so reverse did not work, so screwing up the reverse. That's crazy. So now that I understand the syntax a little bit more, can I see what's wrong with how I tried to do reverse? Let's see. So I took a list in, and then I used a helper. I think that's maybe okay so far. So then we looked at a case where there was E and old, and then I put that on E and new and old. And then when old was empty, we just returned new. Okay. Yes, but I passed them in wrong here. Okay, so I think that did make sense, but then I just didn't do this part right. Okay, so yeah, one failed, one errored. Okay, so which one errored? Unexpected error div? Okay. So that's probably divide by 0, I think. Let's look at the test. Okay, yeah, so here's div, direction-dependent function applied to non-empty list. So the function is x divide y, and we got a divide error. It was expect equal to 0. Okay. I'm just gonna futz with this probably until it actually works. My first guess is that maybe I just had those in reverse. Like, I'm just so done. I'm just about done for it. Let's see. So fold L, but previous clause okay, yeah. Let's see. Oh yeah, that's what that one is. Fold R, and then this one is also R. And fold L should only be here. Okay. Okay, so one error. Okay, so still getting unexpected error div on fold L. Okay, direction dependent function applied to non-empty list. Sure. And okay, so it's still on fold L. So I feel like this might be a thing where we have to reverse the order that things are put into the function. So I think it's a lambda, which we just talked about here. Okay, so I think we want to go fn and I'm going to say xy fat arrow yx. Is that 19 passed? Okay. It's been kind of a long sesh, honestly. I haven't been working through these very fast at all, but I'm going to come back tomorrow and do some more. Okay, so it says submitted. And it says passed. Arc is complete. And okay, so that one's gold. So I've done 6 so far. I'm gonna try for 3 more tomorrow. We'll see how it goes. Tomorrow, when I dive in, it's gonna be straight into Haskell.